This is Math 8, Section 2.1, Understanding Scientific Notation. So before we get started on that, we're going to take a look in your book here and see just why it's so important. We're going to read this little intro. How far away are the stars? When you look at the stars through a telescope, you are seeing light that has traveled an enormous distance. Proxima Centauri, the star that is closest to Earth after the Sun, is about 39,900,000,000,000 miles away, kilometers from the Earth. Numbers like this one are so large that scientists have invented a method called scientific notation to write them. In this chapter, you will use scientific notation to describe and compare very large and very small numbers. So instead of just writing a number 0,000,000, possibly losing count, or taking up way too much space, scientists have given us a way to write this a little bit shorter. It's called scientific notation. For example, a Google, the actual word Google, means a 1 with 100 zeros after it. And that's a Google. We don't want to write out that many numbers. So let's recall some prior knowledge before we get to the actual scientific notation. Multiplying and dividing decimals by positive powers of 10. When you multiply decimal by a positive power of 10, the decimal moves to the right. So if it's positive power, decimal moves right. For example, 1.47 times 10 equals 14.7. Notice the decimal place moved over 1. Now, if we have 1.47 times 100, that's going to equal, we go over 1, 2, so we get 147. If we do even a negative number, but the power is not negative, 1.47 times 100, the decimal still moves over 2 to the right, so it still becomes 147, but in this case it's just negative. Okay, but if we have something with a, well, if we're dividing by something with a positive power, so this is multiplying, but if we are dividing with a positive power, decimal moves left. Okay, the decimal moves left. So if we have 1.2 divided by 10, that's going to equal, it goes over 1, so 0.12. If we have 1.2 divided by 100, decimal goes over 2 places, so we need this extra 0 here, and it becomes 0.012. Works the same with a negative number, not negative exponent, but negative number, divided by 100 is going to equal negative 0.012. Okay, now go ahead and try on your own the quick check. Numbers 1 through 6. Okay, now let's jump right in. So in 2.1, it starts out, understand the need for scientific notation. We already mentioned this a little bit when we talked about the stars and how far away they are. And in your book, you can see there's a picture of the Earth, and it is 380 million meters from the moon. So astronomers have to work with really big numbers. Light from the moon travels to Earth at a speed of 300 million meters per second. Light moves so fast through space that it travels 1 meter in about 1/300 millionth of a second. Really fast. When we're in a decimal, that is 0.00000000333. Not sure if I said the right amount of zeros, but it's a lot of zeros. That many seconds. Very, very short. It's not easy to keep track of all these. So we need to come up with a way to do that. Write numbers in scientific notation. These are just a couple rules of how it should look, okay? So you may write a very large number, a very small number in standard form as the product of a number between 1 and 10, inclusive of 1 and an integer power of 10. What that means is that any number to be written in scientific notation needs to be from 1 to 10. So your number can only be from 1 to 10, but it does not include 10. Therefore, it's including 1, not including 10. So it would look more like this. It has to be the number itself. If this is the number, it can be greater than or equal to 1, and it can be less than 10. So it cannot equal 10, but it can be less than 10. So it could be 9.9999999, but it could not be 10. It could be 1 or anything above that. Okay? These are the numbers that we can use. And then that would be multiplied by that number. It's going to be multiplied by 10. So you would put a little dot for multiplication. To a power. I'll put x as our power right now. So a number, your number is between these two things, including 1, not including 10, and it's 10 to the power of something that it's multiplied by. Let's try an example. 300 million. 300 million equals 3 times 100 million. What we did here was we just took the number out so that we only have something that can be written as 10 to the power of something. So we took out the 3, that was the first number. And notice our number is greater than 1, less than 10, so it works. You can check that. And then this one has 1, 2, 3, 4, 5, 6, 7, 8 zeros. So we see that it is 10 to the power of 8. And that's how it's written in scientific notation. Now let's try something that's a really, really small number. So if we have, let me count the zeros, 1, 2, 3, 4, 5, 6, 7, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8 zeros. 3, 3, 3. Notice how that took me a really long time to write because it's a really, really small number. So that equals 3.33. Now notice, I'm using all of these numbers. I'm taking them all out. And I didn't want to make it 33.3. No, because that is not less than 10. Didn't want to make it 333 because that is not less than 10. I didn't want to make it 0.333 because that is not greater than 1. So it has to be 3.333. Now let's figure out what to multiply it by. So to figure out what to multiply it by, since it's such a small number and we need to move the decimal place this way, it's going to be multiplied by a fraction. Let's figure out how many zeros go here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We had to move it 9 to get to this spot, to get the decimal place to that spot. So in our answer down here, we're going to put 9 zeros. Over 1 billion is what we're multiplying it by. Now let's transfer that to scientific notation. It becomes 3.33 times, check your video, sorry, that's Cherry, times 1 over 10 to the negative 9th, which is equal to 3.33 times, oh sorry, at the bottom it would be only to the 9th. So to convert it to the top, it's going to be not times 10 to the negative 9th. Okay? When you're writing scientific notation, you do use negative exponent, and that is our answer there. Okay, let's try example 1. So in example 1, it says to state whether these numbers are in scientific notation or not. If it's incorrectly, state the reason. So A is 2 times 10 to the 0. 2 is between 1 and 10, so it is correct. B.
Thank God I didn't have to go through this kind of stuff.
Cherry's glad she's not doing math. So Neptune is 4.488 times 10 to the 9th. Is that correct scientific notation? Is this between 1 and 10? Yes. Check. C, I'm almost done. C is The number is 0.01 times 10 to the negative fifth. This number is not between 1 and 10, therefore that is incorrect. D, the number is 10 times 10 to the first. 10, remember, it has to be less than 10. It cannot be equal to 10. Therefore, this is incorrect. Go ahead and try guided practice 1, 2, and 3.